Hi, my name is Ivan. I'm an engineering student with a passion for building in biotech, one step at a time. In this video, you're going to see me going through and showcasing the actual implementation of my machine learning model, which is built on convolutional neural networks. And these neural networks are particularly useful for image recognition and classification tasks. So think in the case of using this, taking image data in terms of medical imaging data, which is MRI and CT scans, and parsing through, analyzing, and using the patterns that are indicative of diseases to actually identify these disease types with this framework and AI tool. So this is like a framework that I used and actually built a model around to actually um, perform this use case, which you're going to see in the video. And additionally, the model may also utilize transfer learning, where a pre-trained network on a large data set is adapted for the specific task of disease detection.
Yeah. So the development of is basically a machine learning model development, and essentially the premise first is that machine learning and disease detection can be solved with software, not just software alone, but like software could be the medium to which disease detection could be solved faster, because in many cases it's disease detection being solved through invasive methods, but I think we can solve it with software and then progressing towards early stage disease detection. So essentially, I implemented the machine learning model using the Notebook, and then imported, of course, TensorFlow, the libraries associated with it to actually develop the model. So there's two things it does, basically. If you look at my VS Code here, you have the data sets, which are transcribed from GitHub. So there's the data set for COVID-19. There's a data set for bacterial pneumonia, um, the tuberculosis, and a few other diseases. So basically, currently, the model has 5 diseases to which there's a huge clinical data set, which it's been verified by clinical professionals. Now, this data sets are now labeled. That's where annotation comes into play. Think of Scale AI, where they label and their data labeling company to label the data sets. But the data that's labeled in this case scenario is medical images. So the whole development here is to actually use algorithms to detect diseases by training the AI to understand how can we differentiate between a COVID image versus a tuberculosis image versus a binaural pneumonia image and others. So in use cases, we can think of it as you take a picture essentially, and the machine learning model will be able to transcribe the likeliness of an individual getting XY disease. And it's very important for us to have some sort of medium, software medium, to allow this to be true, because much people are faced with the hazard of detecting diseases much later and through very invasive methods. So the development here, as you can see, this is the loss and test loss function, and essentially it's basically the function and the code to ensure to what degree is the model wrong. You want to decrease the level to which it's wrong in terms of its analysis and detection. And as you can see, as the epochs, because it's 5 epochs, 10 epochs, 15 epochs, meaning the data constraints to which it's separated increases, the loss function decreases, meaning it's becoming more right, more accurate over time. And you can see a parallel with the accuracy as well. As the epoch increases, meaning the training sets, how much more times it's being trained increases, and it's being more accurate over time. So this is the development of the system, and it continues over this time period. So it gets more accurate over time over the training set. So if an individual was to impute any image that's outside of the current data set, it'll be able to, with 95% accuracy, detect what category will it fall under. Will it be a normal, meaning there's no disease, or will it be COVID-19, as you can see in this picture here, which is a COVID-19 diseased image, or let's say tuberculosis disease image. So development of this model entailed gathering the data, so data sets from Kaggle, which is a machine learning space for image data sets, GitHub resources as well, and then actually fine-tuning the model, pre-processing the model using already existed models that have been labeled and pre-processed, and then actually using feature extraction to extract the specific aspects to the model that we want to use for the detection. And of course, we need to set it to 25 pixels so that all images can be in the same proportion for the AI to understand, and so they can train with accuracy. So as you can see here, it gives it an accuracy. If you input an image, let's say if it gives it the highest accuracy of 99%, which is for COVID, meaning the AI is predicting that COVID is the disease associated with that image. And this is how the model continues to learn and develop. So further use cases of this development, of course, here I'm just going through the code minutely, but further use cases of this development is, number one, for me to actually develop this thing further, like include more data sets, because currently it only has a few data sets. And then secondly, to actually figure out from mentors in industry, what can I add to this model for development use cases? Should I add more data sets, continue the algorithm and implement it and grow the features, or what other use cases can this be useful for?
See you in the next iteration, where I'll increase my implementation to 15 disease types within the dataset and a retrained model that sustains its 95% accuracy.